Hello. Now we need to see another example of nonlinear ordinary differential equation. Okay. And this example for that, dy by dx equal to 1 plus y squared plus 3x squared y over 1 minus 2xy minus x cubed. Okay, the dependent variable for this is y, and independent variable for this example is x. Okay, why it's nonlinear? Because we have the dependent variable has a nonlinear term, which is this y square, so it's nonlinear differential equation. Why it is y? Because y is dependent variable. We don't talk the nonlinearity about the independent variable, which is x. It's no problem if it is x cubed, x squared. So the nonlinearity is come from the dependent variable. Okay, why it is first order differential equation? Because we have only dy by dx here. We don't have d square y by dx square, and so. Okay, so if we rearrange this equation, okay, it will be 3x squared y plus y squared plus 1 dx equal to dy 1 minus 2xy minus x cubed. Okay, if we take this part to the left hand side, we get 3x squared y plus y squared plus 1 times dx plus x cubed plus 2xy minus 1 dy will equal to 0. Okay, and we got this equation, this first order nonlinear differential equation. Okay, this equation in this form, which is p xy, right again, dx plus q xy dy equal to 0. This general form of this equation, because this p is a nonlinear function of x and y, and q is nonlinear function of x and y. Okay, so this nonlinear differential equation is called exact first order nonlinear differential equation if partial p partial y will equal to partial q partial x. This is the necessary condition. If this equation is called exact first order nonlinear differential equation if this necessary condition is satisfied. Okay, write again px and y dx plus qxy dy equal to 0. So if there exists a function called u, x and y, exists a function called uxy, some function of these two variables, such that du will equal to p dx plus q dy. Okay, this will equal to 0. So this form, like this form. So if there exists a function called uxy such that du will equal p dx plus q dy, and this is will equal to 0, and this result from this, because du will equal to 0, any function you differentiate will equal to 0. That means this function is constant. So this means uxy is constant. So if you find this uxy function, then this is the end of the problem, and you solve your differential equation. Okay. Let me go back to and see how to solve this problem. Okay, as you see, this is our problem, this one, and we need to take it and solve. Okay, let me write again. Okay, we have 3x squared y plus y squared plus 1 dx equal to x cube plus 2xy minus 1 dy. Okay, so we have this p x y and this q x and y. Okay, so by the way, from our example, from our derivation for this equation, this will lead us to du will equal to partial u partial x dx plus partial u partial y dy. Okay, and this means this one will equal to p xy and this one will equal to q x and y. Okay, let's go back to here. We have p of x and y will equal to 3x squared y plus y squared plus 1. Okay, which d u by dx as we define. Alright, how to find u xy from this equation? You integrate it with respect to x. Okay, so if you integrate this equation with respect to x, so you get u of xy. Okay, so u xy, you integrate this, you got 3yx cubed by 3 plus y square x plus x plus some function of y some function of y. If you need to to verify your answer, just differentiate this equation with respect to x and you should get this equation. Okay, so if you differentiate for example this, let me okay, if you differentiate with x, you got here what you got here, you got 3x squared y, okay, plus differentiate with respect to x, so you get y squared plus this one will get 1, and this goes because this is not function of x. Okay, this is not function of x. If you differentiate with respect to x, this goes to 0. Okay, this verify your answer. Okay, so now if you differentiate this function, this u, with respect to y, du by dy, what you'll get? You'll get q function, q. Should you get q? Okay, just differentiate this with respect to y. You get x cubed plus 2xy plus f prime of y, which is dfy by dy, this one. Okay, will equal to q function q, which is this one, x cubed plus 2xy minus 1. Okay, this leads us to this one guy will equal to this guy, so f prime of y will equal to minus 1. This means this is called dfy by dy will equal to minus 1, so fy will equal to minus y. Okay, so just substitute this into your equation, into this one, and you get the answer. X cubed y plus x cubed y plus y squared y plus xy squared plus I think x plus fy, which is minus y will equal to uxy, and we said this one will equal to constant. Okay, so this is the solution of your nonlinear differential equation. As I said, this is called an exact nonlinear differential equation because we write it in form of pxy dx plus qxy dy will equal to 0, and we see because we satisfy the necessary condition, which is dp partial p partial y equal partial q partial x. Okay, thank you for watching. I hope this video is very helpful for you. If it is not clear, please leave it a comment. I'll show it in the next lecture and give you some other example in this field. Okay, thank you for watching.